All right, hi everyone. Welcome to Chapter 14's lecture. Chapter 14 is on just in time and lean operations. Chapter 14 is very management theory heavy, a lot of various managerial concepts pertaining to reducing the amount of waste in the manufacturing process or your services or anything else to do with your operations. These are two separate concepts, but they're often combined in one training or even certification. You can get certified in this kind of area, and it can only help your resume as you look for jobs in the operations industry. So, chapter 14, like I said, very theoretical, very management practices, so much so that your quiz this week does not have any quantitative work whatsoever. We do have a few problems we're going to go through from the back of the chapter pertaining to um, minimum number of containers necessary, but other than that, much more on the managerial framework and concepts. So lean operation is one that uses much fewer resources than a traditional system, meaning there's a lot less waste. You're not over ordering on inventory. You're not producing more than you need. It's all about productivity, lowering your costs, and very high quality. And then a just-in-time system is a coordination wherein the entire system moves through right when they're needed, meaning you're not sending a bunch of inventory in to sit up on a shelf somewhere and take up space or cost you money from not being reimbursed for the cost of manufacturing that. It's all about coordinating everything throughout the entire supply chain and production process in order to get things right when they are needed. So some characteristics of a lean system include a reduction of waste. There's even a specific term for that, which we'll learn shortly. Continuous improvement, never resting on your laurels. You're always trying to find ways to improve. Working in cells, meaning you have a group of people that are skilled in the same area or skills complement one another. Minimizing the amount of inventory, very small lot sizes, and then lean culture. It does take a cultural shift and a mindset and a buy-in from management to successfully implement a lean operation. Some of the principles, there are 5 of them. Some of the principles of a lean system are to identify your customer values, focus on processes that create value. So if there's nothing to be gained out of that, whether it's by reducing cost or the amount of time, then it shouldn't be a process worth focusing on. Eliminating any waste, whether it's time or resources or scrap material, any kind of waste or downtime throughout the system to create a continuous flow of processes. Only make what you have a demand for. So doing really good market research, knowing your potential customer or audience, and only making goods or producing services or providing services rather that there is an actual demand for. And finally, striving for perfection. You want to have the least amount of waste, the highest amount of costs, the best quality material that you can. So those are the 5 principles. Some of the key benefits, if you implement this, is that there's a reduction of waste, lower costs, the things we just talked about as far as the characteristics go. Some of the risks, though, is that there can be a amount of stress put on a worker to have that obligation and requirement on them to be looking for areas to improve. And if things go wrong, you don't have a bunch of excess inventory in stock to offset supply chain disruptions or any other problems that could happen. So there are some risks there. Where did lean operations begin? It began as the Toyota way back in the early to mid 1900s. Taiichi Ono and Shigeo Ono of Toyota are the people who originated this concept. So a lot of businesses around the world would send their managers and their directors and individuals to Japan to view how Toyota's factories and production lines were set up, because it was such a well-renowned system, so much that many of the terms we still use in this, Kanban, Kaizen, Muda, some examples there, are still used today. These are all Japanese terms, meaning signal, continuous improvement, and waste. I'll let you draw your own conclusions how waste and Muda might be related, but waste is anything that interferes with or doesn't add value. So again, it doesn't have to be actual waste like scrap. It can be wasted downtime. What's the ultimate goal? Yes, there's many supporting goals, and there's many characteristics and many benefits to implementing a lean operation, but the main goal is a balanced system. A smooth, rapid flow of materials or work or processes or services through a system. So that is the ultimate main goal. Everything else supports that goal. There should be a smooth flow of materials or services or work or anything else through the system that your business runs off of. Okay. Supporting goals, eliminate disruptions, make your system flexible so that you could adjust to ebbs and flows of business, new options and possibilities and opportunities, and then eliminating waste, especially excess inventory, but there are other types of waste, 8 types, in fact. The 8 sources of waste are going to be your excess inventory, overproducing, excess waiting time, moving things unnecessarily, processing the waste, inefficient work methods, product defects, and underused or utilized people. So there's 8 sources of waste in elite operations, but waste is any unproductive resource. Kaizen, like I said a minute ago, Kaizen is continuous improvement. The philosophy for attacking waste says that waste is the enemy, and eliminating waste is necessary. It's necessary to get your hands dirty in that goal. So you should be gradually but continuously improving, not a huge chunks of improvement, but just a gradual and continuous, so that people can make those adjustments and not have a huge world-shattering change in how the operations are being run. Involve everyone from your front line to the very highest position in your company. Implement it everywhere. Be supported by a visual system, so we'll learn what that visual system, what that means, and then learn while doing. So continuous learning, continuous improvement, and what building blocks are there? We've got product design, process design, your personnel, and your manufacturing planning control. So building blocks at play to help you build the lean operations. The first one, product design. Product design, you've got either you have some parts that are standard, but ideally you have a modular design, meaning you can switch out certain components in order to make something else, or you can have one big system that can produce several different things. That modular design is very important in this, because it helps to reduce the amount of waste in processing and use of personnel if they can switch out equipment to make something else. Quality is built into the systems, meaning you are from the very design of it, what can we do to improve the process, what can we do to improve the product that we make, and concurrent engineering as well, producing things alongside with something else so that there's compatibility with one another, or that they make sense for your system. In the process design, there are 8 aspects here. Small lot sizes is the biggest one there when it comes to lean operations. The rest of them listed here, you can pause and read, or you'll see them in your book. But small lot sizes, that's that big one right there. There's a saying that in lean philosophy, the ideal lot size is 1. Yes, you're not always going to be making exactly 1 of 1 unit, but the conceptual idea there is that you're making exactly what you needed. You're never making more than you need. If you only need one thing, you're making one thing, and you never have excess inventory. That would be the ideal goal. Yes, that's a lofty goal. Maybe it's not practical or possible, but that's the ultimate goal. Not having a lot of inventory in process, lower carrying costs. We've seen just how much carrying costs can, snowball and have an exponential cost at if you make things way sooner than you need them, so you're holding on to them month after month. You're never regaining the cost put into that, and you don't need to build excess storage space, etc. Reducing the setup time. So if you can make a small amount of products and quickly change between what a piece of equipment can produce on those modular equipments, then you can reduce wasted time in your setup, and setup cost will come down accordingly. Manufacturing cells, so having a group of people who can do different things in one group, reduced amount of time to change over. You have a lot of equipment utilization because people can do different jobs, cross-train your workers within there. Another process improvement, quality improvement. So any kind of quality defects will disrupt your flow. Something breaks down, or you have to go and change the entire design because there's just so many defects. So ideally, you have a way to automatically detect those defects. Jidoka is the term there for automatically detecting those in the production lines. Flexible work, so reduced downtime. You've got somebody who has no more work to do, well, they can go and do a different job, cross-training your workers to help avoid bottlenecks. Have excess capacity available. So if you have a very important customer who has to get just a ton of stuff all of a sudden without much warning, you have flexibility to move some workers onto those projects. Balancing out your system, so figuring out the amount of total time available, and then balancing the workload throughout the day or the amount of shifts. That's a concept called tack time. We're not really going to go much into that. There are some quantitative pieces we could cover from the chapter that we're not going to get to, but that's that. Let's go ahead and keep going on this. The idea here, what's being represented in this picture, is that excess inventory makes it easy to not realize you have a problem. You have recurring problems that are never resolved because you have all this inventory that kind of make you oblivious to it. So there's all these rocks lurking below the people in the boat here. And there's no reason to address these rocks, even though they're on the path that they go, because there's so much water, right? But if the water goes down, if all of a sudden you don't have that inventory, you have a huge problem. So by reducing the amount of water early, you can tell how many rocks there are, and that's what's going on in the little comic strip here. You have all this excess inventory that makes your problems of getting products to or producing things when you need them not as painful, but you're also carrying all that excess cost. If you didn't have all that excess inventory, you'd realize, oh, you know what, we really have a lot of downtime in our processes, or production capabilities aren't where they need to be. Fail-safe, poka-yoke. It's a long time ago, but I did take 3 semesters of Japanese at one time in my early college days. Fail-safing. So the building safeguards in a process to eliminate potential errors. Some examples of a circuit breaker, right? You have a surge through maybe you drop your hair dryer in the sink and it gets wet. Well, that could cause a huge problem, a shortage in all your electrical systems, or somebody being shocked or harmed in some way. And so in the bathrooms, any outlets next to water, they have the little they're called GFCI, ground fault circuit interrupter, I think is the acronym there. But it stops electricity from flowing and it trips the switch, right? And you can reset it afterwards, but that keeps the electricity from going back into the breaker box, causing a short on all your other systems or electrocuting you, right? So there's a fail-safe there. Your car beeping because you haven't buckled your seatbelt before you get into a crash, right? You leave your car in the ATM machine, it starts beeping at you before you walk away. So these are fail-safes, these are examples, and you can have these in the manufacturing process as well. Your personnel and organizational building blocks. Number one, first and foremost in this is that your workers are assets, your human capital. The skills and knowledge that your workers have should be respected, and you should not treat your workers as a means to an end, but an end themselves and all that. But if you're going to rely on them, you need to also trust them. Cross-training your workers, having a continuous improvement is just a across the board organizational goal, and that's a cultural thing. Using cost accounting, and then leadership, not managing but leading, and then having project management concepts, which you're going to learn in chapter 16. But the idea of implementing project management in order to keep things on track, not go over budget, not go over time on large projects. Here we go, well-trained and motivated workers. So give greater authority to make decisions. The flip side of that is that more is than expected of them. Cross-train your workers for line balancing purposes, continuous improvement. If your workers are knowledgeable about process control, statistical process control, some of those things we covered earlier, the upper and lower control limit stuff, problem solving skills, quality improvement, then they can help and aid in the improvement process. Cost accounting, so allocating overhead to specific jobs makes sense because you can identify where something is taking up too much financial resources. Managers are expected to be leaders, not order givers, is your leadership project management concepts there. Manufacturing planning control, so level loading, make sure that the amount of you've got the things done in the appropriate sequences, that you have workload scheduled in a way that makes sense. You don't have too much on this day, not enough on this day. Pulling things to you. Actually, let's go to the next slide. So level loading, you've got mixed model scheduling. So how many times should you repeat sequences? What should each model? Or rather, how many units do you make during each cycle? What's the appropriate product sequence? So making sure that everything makes sense as far as scheduling processes to be done throughout the daily schedule. Push system, pull system. So in a push system, you've got you complete work and you send it to this department. You complete work, these are all made and they're sent. A pull system says nothing's being sent to my department until I give somebody the signal that I need that, whether that's I hit a light and then it comes to me, or whether I put in a work order, but it's pulled by customer demand or because it's scheduled to do so. This isn't appropriate for all operations. If, for example, there's large variations or variation in either volume, product mix, or product design, it doesn't quite work. But if you have assembly line where everything's coming off of it and we're not sending things through until we actually have a need for that, that's the pull system. Kanban is a card or signal, because it came from like holding up an actual card or lighting a light to say, okay, I need this now I need that. Now it's more or less used electronically or from an order from downstream in the process, computer signal, but it's still, Kanban is still used in there. Limiting your work in process inventory. So again, anything to do with reducing inventory has a lower carrying cost. By not having as much work in process inventory, you have flexibility of making other things from those raw materials or subcomponents. saving scrap or rework. So you have a design change or an order change, you don't have all that work in process stuff scrapped or loss of materials, having to do work over again because you changed something. Additionally, you need to have very close vendor relationships and with a lot of trust, because you are not carrying excess inventory, so you need a lot of frequent small deliveries of really high quality goods. Typically, you have a small number of suppliers, but ones that you can trust, with also backups just in case there's some sort of disruption there. I think that skip ahead. Preventative maintenance. So continuously maintaining equipment on a schedule so that you're replacing parts that often fail before they fail, because if they fail in the production process, that can create a huge problem. So if you've got a belt that's worn out, or gears that are that become loose sometimes, or whatever it is, things that need to be oiled or they'll overheat. You're doing that before they fail, right? This is like getting your engine, getting an oil change before your engine locks up. Continuous housekeeping. So a neat and straight workplace. You've got these the 5 S's here: sort, straighten, sweep, standardize, and self-discipline. But unnecessary materials are not there in the workplace at all, whether that's actually cleaning or never existing to begin with. Value stream mapping. So examining how all materials information is flowing in order to identify any areas or opportunities to eliminate waste. We've got, this sounds like a lot, right? 5W2H, what's that? Well, this is who, what, when, where, why, how, and how much. All right, so questions you would always ask, but continuously asking questions to look for areas of improvement. 6 Sigma. So 6 Sigma is probably something you've heard of, but the idea that 6 Sigma comes from the symbol we use for standard deviation, and all outcomes are within I think within 6 standard deviations of a mean. You've got something like 99.9999997%. So virtually 100%. The idea is striving for virtually 100% on everything. Perfect processes, striving for perfection, basically. Eliminate any kind of variation or errors or defects. So eliminating all defects, striving for perfection. That's the general idea of 6 Sigma. Anyone who's 6 Sigma certified will probably tell you there's a lot more to it than that. There are examinations and certifications you can get in 6 Sigma, and by virtue of having those, you can probably earn a lot more money. They're very 6 Sigma training is very highly regarded in a lot of management circles. All right, let's say that you want to, you're a leader in your company, you want to transition to the lean system. So first and foremost, management has to be committed, not balking at the first sign of trouble and going back to the status quo, but supporting everyone throughout the organization. A total commitment, top to bottom, has to be in place. Figuring out where you're going to have the most amount of problems and addressing those, making sure that they can be addressed before you start implementing it. You've got to get the support and cooperation of your workers. If you don't have buy-in on this, it's not going to be successful. Begin with some small area and then gradually convert to the system. Don't try to make this an overnight switch in every single area of your business, and you're going to have obstacles there. Some of those obstacles include not having certain managers fully committed. If I have, when I worked at the casino industry, if I had a shift manager on my overnight shift who I didn't see very often, and maybe there was an issue with a new process that wasn't fully thought up on how it might affect, the overnight shift. In one place I worked, that person was very vocal about, what a terrible idea I'd implemented. And there was absolutely no support from the workers underneath that manager on that shift, because why would the workers be committed when the manager isn't supporting it, right? So making sure you have the buy-in of your team is just extremely important, or an entire initiative is going to fail. You might have resistance from suppliers. They say, oh, that's not feasible, or I can get a better deal somewhere else, or I'm not going to be that, available to you to get these things done. So finding the right suppliers. And then also, it's just difficult to change people's minds. It takes a full organizational culture shift, and having the right people to be consistent with this philosophy. All right, thanks everyone. That is chapter 14. We will see y'all next time.